spray mist tank, it is possible to use conventional machine tools for deep hole drilling, thus negating the well-known problems of twist drilling at depth. You will be able to achieve excellent size control and surface finish with very little drill wonder. To make this possible, here are examples of what you will require: a spray mist tank and cutting fluid, a Ventec drill tool holder that is suitable for your machine. This will be either a stationary centre lathe holder or a rotating holder for use on milling machine or horizontal borer. Rotating holders are available with straight shanks and Morse tapers. Reduction sleeves may be purchased to make it possible to hold a range of drivers. A Ventec drill. These can be used in stages if you require holes deeper than a 30:1 length to diameter ratio. The longer drill is made microns smaller than the shorter drill, so there is no binding within the bore. A start drill the same diameter as the Ventec drill you plan to use. When using a centre lathe with a spray mist tank, you will first need to check it has suitable speed and feed range. We will be drilling a 6mm bore, so we'll set this lathe at 1700 revolutions per minute at a feed rate of 0.025mm per revolution. Larger drills can be run at faster feeds. Our technical support is always available for any questions of this nature. Your spray mist tank will require filling with cutting fluid mixed at 10%, ideally with warm water, as this aids the mix. This should be added to the tank so you can see a positive read on the sight gauge. Lock the tool holder in the tool post. The lathe's compound slide will also need to be locked so there is no movement during drilling. Use a dial indicator run off the chuck face to set the tool holder parallel to the line of traverse. The bore of the tool holder needs to be true to the lathe's machine spindle. This is easier to do if we get it close first before using a dial indicator. This can be achieved by placing either the drill driver or a reduction sleeve in the chuck. With the tool holder set, the lathe's cross slider datum needs to be set to 0 on the digital readout or on the sight dial, noting in which direction the subsequent backlash is for repositioning at a later time. The workpiece to be drilled needs to be held in the chuck of the lathe. To reduce whipping, the material is positioned in the jaws around the middle of its length. When drilling long lengths of material, it should be supported by a lathe stationary steady. A start hole must be produced for the Ventec drill, so the cross slide must be moved out of the way to give access for the tailstock. With no digital readout, you will need to count the amount of turns that it's moved so you can reposition it later. The workpiece is faced off and drilled using a centre drill in the lathe's tailstock chuck. Where possible, the centre drill cone should be drilled deep enough to not be completely removed by the start drill, as it makes an excellent guide for positioning the tip of the Ventec drill into the start hole without damage. A start hole is now produced with the start drill to a depth of approximately 10mm, or 1.5 times the Ventec tip diameter, whichever is the greater. The start hole will ideally be within H8 tolerance. Position the cross slider back to the relevant 0 that was made earlier on its axis for the commencement of drilling, remembering in which direction the backlash was if no digital readout is available on your lathe. The cross slide now needs to be locked into position. The driver on this Ventec is 16mm, so a reduction sleeve is required in the tool holder. The Ventec driver is locked into position with a grub screw on the driver's flat, which means the flute of the drill is facing away from you. This is so that when the chips are evacuated down the shaft, they are forced in the opposite direction to the machine operator. A funnel, piece of foam, or something of this nature should be placed over the front of the Ventec drill's tip and positioned against the face of the tool holder to aid in deflecting and cushioning the material chips. Place a block on the bed of the lathe in front of the saddle. This serves as a guide to the depth you have drilled if the need to remove the drill occurs to clear a blockage at any point. Be sure to check this block will be clear of the lathe chuck when in operation. Attach the mist head of the spray mist unit to the rear of the tool holder using the quick release coupling. Adjust the needle valve which controls flow so that it is only open roughly half a turn. Move the Ventec drill tip into the start hole. Be sure not to hit the bottom of the hole with the carbide tip. You may need to carefully guide the tip into the start hole when using longer drills by hand. Make sure the air valve is in the off position on the spray mist tank and attach the air supply line. Switch the air valve to the on position. The air regulator will begin to pulse. The frequency of the pulse can be adjusted by lifting the timer adjustment screw and turning in the relevant direction required. It should pulse at least once every second. Be sure to push back into the lock position once set. Once the coolant has primed the pump and the flow ensues in the pipework, it will start to register on the sight gauges. The coolant pressure should pulse between 150 psi to 200 psi. The air supply pressure should be between 80 psi to 125 psi. Before drilling commences, there should be visible droplets of coolant exiting the start hole on the Ventec tip. Start the lathe spindle in motion and engage the feed. As drilling is ongoing, monitor the mist and coolant droplets exiting the hole and adjust the flow using the needle valve attached to the tool holder. At the cutting face, the mist mixture expands, producing a refrigerating effect. The heat from the cutting process evaporates the water content of the cutting fluid, leaving a high lubricity oil. No mist should be evident in the drilling vicinity if this is set up correctly. Chips should be continuously evacuated during drilling. If this is not the case, you may have a blockage. If a blockage occurs, disengage the feed and withdraw the drill to clear it. The block placed on the saddle will show you how deep you had drilled so far. You can then guide the drill back into the hole and have a visual guide as to the depth.